what is the value of k, given that you have open bracket k square minus 2, close the bracket, to the power of 2 equals k plus 2. But let us recall from the algebraic expression that when we have a minus b all in parentheses to the power of 2, as this always equals as when you have a square minus 2ab plus b to the power of 2. So when we apply it here, we have our a to be k square, our b to be 2. So therefore, we are going to have here to be k to the power of 2, again to the power of 2, minus 2 into our a is k square, our b is 2. Then here will also be plus minus 2 to the power of 2. Then everything equals k plus 2. So from here will be k to the power of 4 minus this times 2 times 2 will give us 4k square. Here will be plus 4 equals k plus 2. Then let us take the whole of this expression at the right hand side to the left hand side. This implies we are going to have k to the power of 4 minus 4k square plus 4. Here will be minus 2 minus k. Then we set everything to be equal to 0. So from here we have k to the power of 4 minus 4k to the power of 2 plus 4 minus 2. Here will be plus 2 minus k. Then we set everything to be equal to 0. Now, from here, we can factor k to the power of 2 outside from this and this. So we have here to be k to the power of 2, k to the power of 4 divided by k to the power of 2. We are going to left with k to the power of 2. 4k squared divided by k squared. Here we will only minus 4 as this. So here will be, from here, let us factor minus outside. Between this, we only have minus into k minus 2, everything equals 0. When you open the bracket with minus back, we have here to be minus times plus here, will give us minus k. Minus times minus, we have here to be plus back, we have plus 2. Then we have here to be k. So we have here to be k to the power of 2. Here will also be k to the power of 2. We can have 4 as 2 to the power of 2 as this. Minus open bracket k minus 2. We close it. We set everything to be equal to 0. This is the difference of 2 square. Remember when you have a square minus b square always equals as a plus b all in parentheses multiplied by a minus b as this. So when you apply it here, definitely here will be k square outside. Here will be k plus 2 again multiplied by k minus 2 minus open bracket k minus 2. We close it. We set everything to be equal to 0. Then from here, we have k minus 2 in common, so we can factor it out as k minus 2 as this. So we open another bracket. The whole of everything here divided by this, we are going to left with k square multiplied by k plus 2. The whole of this divided by this, we have only minus 1. We close it. We set everything to be equal to 0. Here will be k minus 2 in parentheses. Open this bracket with this, we have k to the power of 3. Open this bracket with this, we have 2k square minus 1. We close it. We set everything to be equal to 0. Then what are we trying to say here is that for this particular expression to be equal to 0, is either we have k minus 2 equals 0, or we have k to the power of 3 plus 2k square minus 1 to be equals 0. Then from here, it is obvious that we are going to have the first solution as k will be equals 2. Then, likewise from here, we have this to be equals this. Then let's use proof by inspection. When we inspect k, when k equals 1, when k equals 1 from here, just we have here to be 1, here will be plus 2 minus 1, and this does not equal 0. So we reject this. Okay, when k equals minus 1, let's see what will happen. Minus 1 into this, we have here to be minus 1 plus minus 1 into this, we have 2. Here will be minus 1, and this will be equals 0. So therefore, we get another solution to be k equals minus 1, as because the left hand side, this root satisfies this polynomial equation. So therefore, we have another value of k to be equals minus 1. Then let us get another solution. Then we are going to apply the division of polynomial from here. So by inspection, we suggest that k equals minus 1 satisfy this expression, and this implies that k plus 1 equals 0. This one is a divisor, while this one is a. So now let us apply division of polynomial, where we are going to have k to the power of 3 plus 2k squared minus 1. Here will be k plus 1. So from here, what we are going to have will be this k to the power of 3 divided by this k. Here will be k to the power of 2. Then let us multiply k times k to the power of 2. Here will be k to the power of 3. This plus 1 times k to the power of 2. Here will be plus k squared. So we subtract. So here will be 0. This minus this will give us k squared minus 1. We take this one down. Then again, this k to the power of 2 divided by this k, we only have plus k. Now, k times k will also give us k squared. Then 1 times k will also give us plus k. Then we also subtract this. This and this will give us 0. Then here will be minus k minus 1 as this. So having known that one, so we come here again, minus k divided by this k, here will also be minus 1. And so therefore, we will say k, this k times minus 1 will give us minus k. Then this plus 1 times this minus 1 will give us this minus 1. We also subtract this. When we subtract as this, so here will be 0, 0 as this. So at this, we have this one to be 0, 0. Therefore, when we multiply this and this, will give us back, that is our k to the power of 3 plus 2k squared minus 1, equivalent to, as when you multiply this, k plus 1 multiply by this k squared plus k minus 1 as this. But remember, everything equals 0. Now from here, we believe that we can get this using quadratic formula, as we are going to get k plus 1 equals 0, or we have k squared plus k minus 1 to be equal 0. Obviously, we've got this already to be k equals minus 1. So now, let's apply the quadratic formula to get the other solution. So we are going to have k equals minus b, positive or negative, square root of b squared minus 4ac divided by 2a. So we have a to be equals the coefficient of k squared, 1, and b to be equals 1, and c to be equals minus 1. So when you plug in everything here, we are going to have our k to be equals minus 1, positive or negative, root of 1 into 4 multiplied by 1 multiplied by minus 1, all divided by 2. So we have k to be equals minus 1, positive or negative, root of 5 divided by 2 as this. So we also get another solution. Finally, we are going to have k to be equals minus 1. We also have another k to be equals 2 as this. Then we also have, let us know this one is K1, this one is K2. Here we are going to have both K3 and K4 to be equals this. So if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. Bye bye.